पावर प्लांट क्वेश्चन आंसर में आपका स्वागत है। अगर आप बीओई या बॉयलर ऑपरेटर एग्जाम या इंटरव्यू की तैयारी कर रहे हैं तो यह चैनल आपके लिए बहुत हेल्पफुल होने वाला है। चलिए शुरू करते हैं। What care is taken while charging a steam pipeline and why? In cold conditions, special care is to be taken to heat up this steam line and allow thermal expansion gradually before getting full load on the turbine. First of all, drain are open before charging steam line. After the condensate is drained out, the main steam stop valve is opened slowly. Drains are throttled slowly and closed when no more condensate but only dry steam is coming out from the drain. Steam traps provided in the pipelines are kept in line once the drains are closed. If a vent is provided in the pipeline before emergency stop valve of turbine, then this is open to allow steam to flow so that the pipe line up to AUSC can be heated up. It is to be ensured that the expansion is not restricted anywhere. Once the pipe line is heated, stop valve of the boiler can be opened fully. What precaution is to be taken to start bearing operation of a turbine? Before rolling turbine is to be put on bearing operation. Following steps are followed for bearing operation. Ensure the lube oil system is in service and oil is circulating at all bearings at a desired pressure. Start the jacking oil pump if provided to lift the rotor. Engage the bearing gear clutch. Start the bearing gear. Observe the rotor is rotating at bearing speed without increase in bearing vibration and temperature, and there is no abnormal sound. What is the function of hogger ejector and what sequence is to be followed to charge the main ejector? Vacuum build-up. Starting ejector or hogger. 1. Ensure the auxiliaries steam is available at the desired pressure and temperature. 2. Ensure the vacuum brake valve of condenser is closed. 3. Ensure cooling water is circulating in the condenser and the turbine gland is charged fully. 4. Open the steam valve of the starting ejector. 5. Observe the steam is vented to the atmosphere. 6. Open the ejector air valve. 7. Observe vacuum inside the condenser is increasing slowly. Main ejector. 1. Ensure the condensate extraction pump CET is running. 2. Open the cooling water inlet and outlet valves of the ejector condenser which is put in service. 3. Vent out air from the water box of the ejector condenser. 4. Open the condensate drain valve of inter-ejector condenser and after ejector condenser of that ejector which is connected to the main condenser. 5. Open the steam valve of after condenser ejector. 6. Open the steam valve of inter-condenser ejector. 7. Observe the condensate is drained out from both the condenser. 8. Slowly open the air valve of ejector and observe vacuum is increasing. Main ejector out of service. 1. Stop the air valve of ejector. 2. Stop the steam valve after condenser ejector. 3. Stop the drain valve of inter and after condenser. 4. Stop the water inlet and outlet valve after the condenser is cooled. Define cold start-up and hot start-up of turbine. In cold start-up, turbine is started from cold condition. In this case, special care is taken to heat up the casing and rotor for the proper thermal expansion. As both the rotor and casing are in cold condition, it requires longer time to heat up, but in case of hot startup, both the casing and rotor are in hot condition. So it can be started with in a short period. What is turbine startup curve? We should not enter the steam immediately to the turbine, as it may damage that turbine due to uneven expansion. When turbine rotates on such a speed that frequency of shaft becomes close to its natural F frequency, thereby causing noise and high vibration in the machine because of the resonance. It occurs at a speed called critical speed. Running of steam turbine at this speed is avoided. Beyond the critical speed, vibration becomes normal. So starting curve is that turbine take time to reach at full speed during cold startup or hot startup. What is the critical speed of a turbine? When turbine rotates on such a speed that frequency of shaft becomes close to its natural frequency, thereby causing noise and high vibration in the machine because of the resonance. Shaft becomes dynamically unstable and large vibration is developed. It occurs at a speed called critical speed. Running of steam turbine at this speed is avoided. Beyond the critical speed, vibration becomes normal. What are the main emergency conditions of a steam turbine? Steam turbine is a critical rotating equipment. High temperature and pressure steam is used to rotate the turbine at high speed. Mass of the rotating part is more. There is always chance of server mishap, leading to a fatal accident and damage to the high-cost equipments. Overspeed, failure of lubrication oil system, high vibration, high bearing temperature, blackout condition, failure of bearing device, high condenser hot well level, high axial displacement, leakages, fire, low steam parameters, high steam parameters, low condenser vacuum, failure of cooling water system, failure of plant automation system. Why is low inlet steam temperature not recommended in a steam turbine? Unsaturated steam enters turbine and damage it severely due to low temperature steam is condensed towards the last stage blade of the turbine. It also produced thermal shock on the hot turbine. So turbine should be stopped immediately. Why is overspeed of steam turbine so dangerous? Rotor is designed to rotate momentarily up to 110% of the rated speed. At higher speed, rotor stress increases. Due to high centrifugal force, the blades which are fixed to the rotor may come out due to the failure of blade root and cause severe accident and damage to the turbine. What action should be taken when the bearing device fails? When turbine is stopped in hot condition, it is not recommended to keep the rotor at standstill in this situation. By any means, the rotor is to be rotated. The rotor position may be changed by 180 degrees continuously at some intervals by manual. Why should the turbine be stopped in case of low vacuum? Due to the vacuum in condenser, the steam from the turbine is easily exhausted into the condenser. If vacuum inside the condenser drops, it restricted the exhaust of steam. Back pressure is created inside the turbine. So turbine should be stopped immediately. Why is the high condenser hot well level so dangerous? Due to the problem in CP or any other equipment in condensate system, condensate cannot be evacuated from the hot well. So, the hot well level becomes high. In this situation, water enters the turbine through exhaust hood. The condenser vacuum reduces drastically in this condition. In case water enters a running turbine, it creates a serious situation and damages the turbine, so turbine stopped immediately. What precaution is taken to reduce the throttling loss at control valve? To minimize this loss, instead of a single valve, multiple valves are connected to a common operating lever and placed in such a way so that a particular valve opens at a particular position of the operating lever. Steam enters the turbine through these valves. This is taken care during the design stage of turbine. What is interstate leakage loss and when does it happen? There is a pressure difference in each blade stage of turbine. Due to the leakage of steam between these stages, steam passes to the next stage having lower pressure without doing any work. This loss increases due to the damage of fins at the blade tip and interstage seals. What is gross turbine heat rate and how is it calculated? Heat rate is a means to express thermal efficiency of a power plant. Normally it is expressed in kilocalorie per kg watt-hour. Less heat rate means the cycle efficient. Energy input is the steam mass flow rate to the turbine multiplied inlet steam enthalpy. Energy extracted is the enthalpy of total extraction steam plus the heat available in condensate. Gross turbine heat rate can be determined by dividing the heat added to the boiler between the feed water inlet and the steam inlet of turbine by the kilowatt output of the generator at the generator terminal. Feed water heating is done through extraction steam to reduce the heat rate. Gross turbine heat rate is equal to heat added to the boiler per kilowatt output of generator or enthalpy of steam minus heat in feed water divided by kilowatt output of generator. What is gross plant heat rate and how it is calculated? Gross plant heat rate kilocalorie per kg is determined by dividing the total heat energy kilocalorie per kg in fuel added to the boiler by the gross kilowatt output of the generator. What is combined cycle technology? A combined cycle power plant works by integrating the Brayton cycle of a gas turbine with the Rankine cycle of a steam turbine to generate electricity efficiently. The gas turbine uses the Brayton cycle, while the waste heat from the gas turbine's exhaust is used in a heat recovery steam generator, HRSG, to produce steam, which then drives the steam turbine on the Rankine cycle. What is the function of heat recovery steam generation HRSG in a combined cycle power plant? Heat recovery steam generator HRSG is a heat exchanger that recovers heat from the hot exhaust gas of the gas turbine GT. It's produce steam, which is used to drive a steam turbine. Steam is produced at HRSG like any other fired boiler system, but without any firing furnace. What are the three sections of gas turbine GT? Gas turbine runs on Brayton cycle. GT has three main sections that are compressor, combustion chamber, turbine. What are the approximate efficiencies of subcritical, supercritical and ultra-supercritical power plants on LHV basis? Subcritical unit, 38% to 40%, supercritical units, 40% to 42% and ultra-supercritical unit, 43% to 46%, the net plant efficiencies on LHV basis. What is the difference between supercritical power plant and ultra-supercritical power plant? The unit operated at the steam pressure, 225 kg per centimeter square and superheat per reheat temperature up to 593 degrees Celsius are called supercritical units, whereas the unit operated at pressure above 225 kg per centimeter square and superheat temperature more than 593 degrees Celsius are called as ultra-supercritical unit. What are the benefits of SC and USC power plants? Benefits of supercritical SC and ultra-supercritical USC power plants are less fuel consumption due to higher plant efficiency, less CO2 emission, better availability, less NOx, SOx and particulate emissions, possibility of large unit size. How much carbon dioxide gas is generated per megawatt-hour of power generation in thermal power plants? About 0.95 ton carbon dioxide gas is emitted per megawatt-hours of electricity generation. What is the process of IGCC power generation? IGCC plant uses a gasifier to convert coal or any solid fuel into synthesis gas or syngas, which is used for power generation by the combined cycle technology. Gasification is the process of converting coal to gaseous fuel through partial oxidation. What is steam turbine VWO condition? Turbine is designed to operate at approximately 105% of the normal pressure. This inherent design margin can further be used to generate around 5% more power at VWO valve wide open flow. So, Around 110% of the rated power can be generated at VWO OP condition. Set can be designed to run on this load for short duration during emergency. What do you understand by BMCR and EMCR? BMCR, boiler maximum continuous rating, is designed to support VWO flow of turbine. In normal engineering practice, 2% margin above VWO flow of TG is considered for BMCR. EMCR, economical maximum continuous rating of the set on which an optimum heat rate of the set is obtained. Normally, a turbine is designed to deliver guaranteed performance at the designed parameter on continuous basis. This is also called rated capacity. दोस्तों, अगर आपको कोई टॉपिक चाहिए या कोई खास सवाल सीरीज चाहिए तो मुझे कमेंट में जरूर बताएं। मैं अगला वीडियो उसी पर बनाऊंगा। चैनल को सब्सक्राइब और शेयर करना ना भूलें। मिलते हैं अगले वीडियो में।